Remember what I said in the first video about my homemade engine? I'm a yokel, I'll make everything as always in my yokel manner, with a grinder, a hammer, a chisel, and tons of curse words. What do you think? A lot has changed? Absolutely nothing. If you remember from the first video, I had pieces of thick square metal from which I wanted to make seats for the crankshaft bearings. So that's where I got stuck because I couldn't find a turner who would agree to do it. It took me a couple of months to find a lathe guy who agreed to machine me what I wanted. And in the end, he took a pile of money from me, plus he didn't turn them on the outside, so he left them square. So the very first work I did on my own lathe was these flanges. I machined them from square to round. Next, I pressed the bearings onto the crankshaft and pressed the flanges onto the bearings. Then I piled it all together and, with a smart look on my face, ran around with a tape measure, figuring what kind of piece of metal I'm gonna need for all this. At first, for this part of the block, I wanted to take a piece of metal from a Gas 52 frame, but the problem was that at some point I felt bad to cut this frame simply for metal. I dug a 1/4-inch thick metal stripe from my scrap pile, measured it, cut 2 pieces, chamfered it, and welded it together. Then this blade had to be shaped like the future block, and after trying with the universal tool, I realized that it would take a lot of time. After that, I went to the press and literally in a few minutes I got exactly what I needed. First, I decided to make the lower part, then make the side parts in relation to it. When the bottom part was ready, I began working on these side plates. I wanted to make these plates from at least 8mm steel, but again, I didn't have such a piece of steel, so I also made this plate, but from 8mm steel stripes this time. Everything here is exactly the same as these plates. I cut off several pieces, chamfered them, aligned them, and welded them. Since I didn't have such a piece of metal, I wanted to make this front part from stripes as well. But while I was welding this rear part, I got a call and a man told me that he found a piece of a flat plate and he'll give it to me, no charge. A saint person. And the fact that it was straight and level played a very important role, because in relation to this plate I aligned the crankshaft and the cylinder's platform in the future. Next, in these 2 plates I had to make holes for the bearing seats. I drilled a bunch of holes, knocked out the middle part with a chisel, and gave it a round shape with a file. You'll ask me, why didn't you make the holes on a lathe? Because to make a tool to fix it on a lathe would have taken me longer than the way I did it. I could have made the holes with a hand drill, but I would die while drilling a ton of holes in an 8mm plate with a hand drill, so it was finally time for the drill press, which my cousin gifted to me, for which I'm super grateful to him. I planned to clean and lubricate the bearings in the motor, clean and lubricate the spindle, but time was tight, so for now I just took the motor off, reconnected it to a triangle, connected it to the frequency converter, the motor launched, and with it the drill press started working as well. And I must say, as a guy who's never in his life worked on the drill press and always drilled all the holes with a hand drill, I was simply shocked by how convenient it is to work with a drill press. So before drilling this plate, I marked the approximate position of them holes and cut off all the excess from the plate. Don't worry, I'll take the drill press apart a little later and maintain it. The holes are ready and I can commence working with my favorite tool, and even more, with a chisel. Like a glove, and then another folk instrument, a file. That's it, the orifice is ready. Approximately fitted it in place, chamfered this giant horseshoe and tack welded the back plate in place. Then I did the same with this flat plate. Also drilled holes, knocked out the middle part with a chisel and gave it a rounded shape with a file. At first this flange with bolts was supposed to be inside of the engine, but this created a problem because the crankshaft would hit against this flange when being removed out of the block. As a result, the whole day of work that I had spent on this flange was worthless because I had to redo it and put it outside of the case. All this time, the crankshaft was with a temporary pin, and accordingly, in order to assemble the block, it was time to press in the main pin. To do this, I warmed up one flywheel, pressed the pin into it, cleaned and lubricated the bearings and rods, assembled them, warmed up the second flywheel and pressed it all together. The press fit turned out to be very strong. I can't even imagine what should happen for it to unpress. To my surprise, the flywheels assembled pretty straight from the first try. Of course, I didn't put it into a truing stand with micrometers because I didn't want to get a heart attack nor to break the stand. The less you know, the better you sleep. Next, I drilled all the bolt holes in this plate, bolted the flanges, tried it all in place, tacked it, and then welded it with a 4mm electrode. Then also with a 4mm stick, welded the back plate to this horseshoe. Also made a couple of flanges that'll serve as guides for this cover, and welded them on the inside. Next, I shoved the crankshaft into this burn house. And a whole epic began with its aligning. I won't show you how I aligned it because it took a very long time, but the only thing I can say is that I aligned the crankshaft in relation to this plate so it's all square, and because it's square, it'd be much more convenient to align the cylinders plate. And after 1,000 removals and insertions of this poor crankshaft from this burn house, I finally tacked the bearing seats in place. Then I began playing with setting up this platform for the cylinders. But first I decided to weld the bearing seats and a big problem awaited me there. Remember the first video? But it turned out that this plate was a little hardened and quite difficult to process, so now I need to anneal it and give it to the turner for machining. And I did anneal them, but they turned out to be high carbon steel and the welding simply unglued from them. And when I was almost ready to machine new bearing seats, I decided to try and weld these with stainless steel rod. Fresh stainless electrodes I had only for a couple of tacks, but even this made me understand that with stainless steel weld, it would work. Since the stainless weld didn't unglue from this metal no matter how much I hit the seats with a hammer. It was time to buy stainless electrodes, but then I remembered that I had several Soviet stainless steel electrodes lying on a shelf, which my father once gave me, for which I'm super grateful. I decided to go ahead and try them, and it turned out that they weld 1,000 times better than new made stainless steel electrodes. But they only worked at the maximum current that my welder produced, namely 250. I welded both bearing seats with stainless steel and I was very pleased with the result. It's really not bad for a 40-year-old electrode. I'm sure that nothing will fall apart, and even if it will, well, I'll redo it anew, it's not that big of a deal. Then when the bearing seats were welded in place, it was finally time to set up the top plate and weld it. I won't show you how I was setting up the cylinders platform because it's a total nonsense. I can only say that a corner ruler was involved in this whole process. But still, the block turned out to be very straight and square. I spent several days setting everything up, so this case is actually pretty nice. I'm also confident in the welds. You can install a Christie Fire 20-liter engine top end here and it'll withstand it. Next, I made a bolt flange for the top of the lid. I cut threads in it and welded nuts to the back of it for extra reinforcement because it's just raw metal. Welded it to the case, ground the welds and put the lid back on. Also, here to all these bolts I'll need to weld additional nuts later because this is also just raw steel. The case with the crankshaft without the top end weighs 40 pounds. I understand that for such a small displacement the block may have turned out to be too strong. I could have chosen much thinner steel for it, but I like everything to be a bit extra, so that's why I chose thicker plates. At this point we can assume that the case is finished. Next will be the oil, ignition and fuel supply systems. Despite the fact that everything looks pretty quick and simple, it actually takes a lot of time. And specifically what you just saw took me almost a month of daily work. Especially a lot of time goes for all sorts of little things and for correcting various mistakes that I make simply because I'm too lazy to sit down and think twice. For example, one night I had to assemble and disassemble the crankshaft 3 times because the rear rod was slightly rubbing against the flywheels, and the reason for this is that I simply didn't bother to double check everything during the first assembly. I hope it'll continue to be just as warm as it is now so I can finally start building the cam chest, because honestly I can't force my laziness to work in cold weather. Oh man, what a mess this garage was. Seriously, I drug a bucket of abrasive dust out of here. Good thing that the angle magnet never fell on the floor. Dang it. I'll see you in the next video.